last video we started with the design of a half order. We also exercised as how to develop a Verilog HDL program for a half order circuit. Okay, that is a very simple one. In this video we are going to look after the design of a full order circuit using the Verilog HDL programming. That is what we are going to do. And the screen what you are seeing is that Verilog coding for the half order. I have already developed the program for the full order. Let me copy this full order program and put it in the module. Okay, and just copying it. Let me explain what is this actually. These are all unwanted codings, so I am just deleting this. Okay, now you can see in the top module is full order and the bottom module is the half order. Now in the full order gets 3 bits, A, B and C in. These are all the 3 inputs. Okay, it generates 2 outputs, sum and carry. So outputs are declared as sum and carry. A, B and C in are declared as the input. Now you can see that the half order coding is invoked double the time. Now what is the module name of the half order? It is given as H order. Here the H order is invoked twice, 2 times. This concept is called as the module instantiation. It means that the full order is nothing but the combination of 2 half order. So using that concept I have developed the coding. The half order will be invoked twice. After we invoke the half order circuit diagram, the carry generated from the 2 half order will be again ORed, logically ORed. Based on the logic operation OR operation, we are getting the carry output, and the sum output will be generated when we perform the half order addition for the second instantiation. So that is what the coding. In the first half order we are getting the AB, and AB will be passed to the half order as an input. Sum and carry will be generated as an output. Now these two sum and carry are the temporary sum and temporary carry. Therefore these temporary sum and temporary carry are stored in the wire, and TC2 will be generated as the second carry, and TS temporary sum and Cin will be applied as an input. So we are getting the final sum in the next half order addition. Okay, so now let me save the program, and I click on this half order. I expand the ISIN, verify for that behavioral check. If there is any error in that, it doesn't have any error, so you can see that it is showing the green color indication. Let me double click on the simulate behavioral model. Let me click on the behavioral model. Let me now change this into 10 nanosecond instead of this 1 microsecond. I can apply the inputs. A, B and C in are the inputs. So I apply the input A to be 0 and B as 1. I apply C in as 1. So let me run the application. Now you can see that this is run for 10 nanosecond. I can zoom out, and what is the actual output for only 10 nanosecond. We can see this clear. So for that is we are adding the input of 1, that is A is 0, B is 1 and C is 1. So 1 plus 1 is 1 0, therefore sum is 0 and the carry is 1. Let me apply the input of A to be 1, therefore B and C are already 1. B and C are already 1. All the 3 inputs are now 1. Therefore you can see that sum and carry are 1 and 1. Means that 1 plus 1 is 1 0, 1 0 plus 1 is the 1 1. Okay, so this is the simulation. In the same way we can whatever the possible combinations. So here we are applying 3 inputs, A, B and C in. So 2 power 3 is equal to 8. There are 8 possible combinations wherein you can apply the inputs. For each and every possible combination of the input you can check the output. I have verified only for 2 inputs. In this way you can check for the remaining possible combinations also. Okay, so in the similar way I close this simulation, and I go to the implementation. I double click on the synthesis part. Once it is completed, I can check the view RTL schematic. Let me wait for that. Now it is completed. Let me double click on this view RTL schematic. Let me select the full adder, add it, full adder, create the schematic, and I can float this. I double click on this, and see this window is not needed. Okay, so I double click on this. This is not needed. I can zoom out, so I can see this is the equivalent resistor transfer logic for the given full adder circuit. Now you can see what is the half adder output of the first one and the second half adder output. Both are logically OR, and we are getting the carry, and here we are getting the sum. Now what is inside the half adder? I can double click on this. You can see that the circuit diagram for the half adder. Again here also you can click on the XR. You can see this coding. So the half adder RTL schematic we have already seen in the last video lecture, and this is the complete logical coding for the half adder coding. In the same way we can also expand this one. So again I can double click on this. Now this is the complete coding for the full adder. Is it clear? Okay, this is one half adder and this is another half adder. Here we are getting the sum, and here we are getting the carry, and here we are getting the what is called the sum. Okay, is it clear? You can exercise this experiment. Thank you.